Good morning, everyone. Today we are going to see the regression and how do we calculate regression. So, in the earlier chapters, we discussed about correlation and chi-square, and the next step is regression. So, agenda for today is introduction, and then we will see three different use cases of the regression, and then finally, what is the takeaway, and then any Q&As. Okay, so what's a regression? So it's basically how an independent variable is related to the dependent variable. So in case of correlation, we saw that there are two variables and we found out, okay, whether there is a relation exist between these two variables. So regression is one step on top of it, where you're trying to find out, okay, if you are having an independent variable, how the dependent variable changes when there is a independent variable changes, and it is usually used to predict the dependent variable. So in simple terms, it can be represented like, for example, beta 0 y is equal to beta 0 plus beta 1 plus x. So once you have that data, observed data collected, you can plot it and you can find the fitted regression line. So what is fitted regression line? So it's basically a line connecting, basically it's a common line through the observed plotted variables, but it is plotted in such a way that it minimizes the sum of the squares of vertical deviations of the specific the plotted data points to that line. So in simple terms, for example, if you're having the best fit line, right? So it is from the line to the specific point that is called residuals. So basically the sum of the squares, right, so of the residuals, and if you try to minimize that, then you draw a regression line according to that. That's called fitted regression line. And what is r squared? So r squared is the measure of how these data are close to the fitted regression line. So for example, if it is just on top of the fitted regression line, that means it's a very high regression exists. Um, Next, confidence intervals. So, what is confidence intervals? It's primarily how the intervals, basically how the data is distributed, right? What is the confidence level? So, usually it is represented in 95 percentage or 99 percentage. Okay, so next we will move on to the three different use cases. The first use case is the debt versus income, right? The debt and the income. So in this use case, the regression coefficient, we are saying, okay, the regression coefficient is 0. That's the null hypothesis. The alternate hypothesis is the regression coefficient is non-zero. The regression coefficient is nothing but the slope, basically. So we found the linear regression using the PSPP, and then whether debt can be predicted from the income, right? So that was the evaluation done, where debt is the dependent variable, income is the independent variable. So as a part of that, no significant regression was found. Why there is no significant regression was not found? If you see the p-value, it is 0.5, which is much over the alpha, which is 0.05. And similarly, the regression r squared, right, it's a 0. So here is a result. So for example, um, as you can see, the r squared is 0, and this p-value is 0.535, and also the confidence interval is minus 0.01 till 2.01. So generally in the confidence interval, if it passes through 0, then that means there may not be any regression exist. Okay, let's move on to next use case. So in this one, there is a regression between income and the savings. So basically, whether savings can be predicted from the income. That was a question. So here the regression coefficient is 0, that's the null hypothesis. The alternate hypothesis is the regression coefficient is non-zero, right? So we wanted to find out whether savings could be predicted from the income. So we do the regression, the simple linear regression using the PSPP tool. So statistically significant regression emerged. Why is that? For example, when we did the analysis using the regression, the p-value is 0, which means which is much lower than the 0.05. That means it is statistically significant. And also the r squared value is 0.82, right, which is much higher. And also the beta is 0.91. So that means there is a strong slope exist. So if you really want to predict the savings, you can calculate by like 0.91 into the income plus constant. And basically the savings is predicted to increase as the income increases. So what's the confidence interval in this case? 95% confidence interval. It's basically 0.09 to 0.11, and it does not pass through the 0. So that means it is basically supporting the regression and we can predict the data. So here is the data we pulled out from PSPP. So as you can see here, the beta is 0.91 and upper bound and lower bound of confidence interval are here, and the p-value is 0. Okay, going to the third use case, stocks and savings. So the question here is whether stocks could be predicted from the savings. So the null hypothesis is regression coefficient is 0, and alternate hypothesis is regression coefficient is non-zero. So a simple linear regression was plotted, and then to find out whether stocks could be predicted. And then we using the PSPP tool, when we analyze the regression, we got the p-value as 0.000, which is much lower than 0.05. So there is a significant regression. And when we see the beta value, it's a 0.28, and the r squared value is 0.07. And thus the test null hypothesis can be rejected and savings can be predicted. And the confidence level here are 0.07 to 0.25, and again it does not contain 0. So here is the details from the PSPP. Okay, so what are the final takeaways? Basically, using the regression, we can predict the dependent variable. So when we wanted to do the regression, we wanted to first state the hypothesis about the regression coefficient, and then the next step is we have to establish the significance level. Once we have that, we have to determine the slope of the regression line, how it is, whether it differs significantly from 0. To do that, we need to do the standard error coefficient test statistic, and we can calculate the p-values. There are many tools which can do this. PSPP is one of the tools which can do this. And then finally, we determine the r squared and the confidence interval. So once we have all these data collected, we can decide whether we can accept or reject the null hypothesis. Okay, thank you so much for listening. If you have any questions, please add it in the comments. Thank you.